don't split. An example of what radiation is a radioactive isotope is basically can be demonstrated here with this toy. Okay, now let's see. I don't have enough light, darn it. Take this. Okay. Now, very easy demonstration. Now you see the ship. You see how it's kind of like here. Okay, now uranium atom, or the kind that they say splits, basically it is bonded to other atoms, right? Okay, so pretty much as long as it stays here, it's fine. And what it is basically is there's other atoms basically around it holding it in place. Once those atoms get used up, it'll fling off itself. Once the pressure from the other atoms basically gets moved away, like for instance, if there was another atom, pretty much, if there was another ship pretty much on top of this. Now, once that other atom goes like that, then this one will sit here and want to go. This one will want to fling off too. Basically, it's a as long as there's other atoms in front of it, it's fine. It's held in there and it's sitting there going like this, wanting to move. And it kind of like it's a weakened electromagnetic bond is what it really is basically. The bonds around it wants to break free basically, and then once those other in the 1920s and 1950s they actually explained it a lot better. Basically, there's individual all kinds of molecules basically, and these other molecules want to break free, but they can't break free because there's a molecule or something in front of them holding them. Now, once that other molecule, and basically heat and temperature, basically these elements are stable as long as they're cool. When they're cold, they're stable because they can't really move around that much. But when they start getting hot, because what happens is whenever anything gets hot, the bonding of it gets weakened. A good example is basically if you had a girlfriend and she was like all hot and heavy and she wants to have sex, but you don't want to have sex. So what she'll do is she'll zing off to the next guy that does want to have sex. So that's an example of a nuclear reaction. That's a better example of a nuclear reaction. They used to explain this better in the what's it called? Basically, pretty much like basically as everything gets hot around it, the heat makes the bonding of the atoms basically get loose. So basically, they want to break apart. Now, these items actually get and these ones break apart at a high speed. Their bonding is actually harder, or they're more attracted to everything. So when they do finally zip off, they zip off at a much increased rate. Anyway, it's complicated, and I'm not really explaining it right, but that's a better explanation of nuclear physics. They don't split. They don't split. They're basically the heat makes the bonding, the molecules when they're bonded. It's electromagnetic bonding actually, or something like that. Basically, the electromagnetic bonds get weakened with heat. Heat has a weird electromagnetic response that is not like anything else. Anyway, it's all complicated. It's all physics and numbers and math and everything else like that. And if you go through like 50 years of school, you can kind of understand it a little bit better. I did understand it at one point in time. I was like, yeah, whatever. Anyway, mostly they were building up inside of my smelting pots. The what's called the uranium was always building up inside my smelting pots. So I consider it hazardous waste and just a problem. Like I said, at 100,000 degrees or a million or high temperatures, what you get in the smelting pot, because you get gold, silver, you get aluminum fuzz on the top, then you get gold and silver and all these other different elements. And what you get at the very, very bottom of everything, it'll coat the inside of the container, is uranium. So when you're pouring it out, basically you always get this blackish ring or this blackish metal stuff that forms up on the inside of the containers. And that stuff is highly radioactive and all that other stuff. So basically it's pretty much a byproduct and basically something that's more of a nuisance to the smelting industry, because when you're working at 50,000 or 100,000 degrees, you always get this residue that is basically uranium oxides. So anyway, And it's also very hard, and you could also use it for other things like re-entering atmospheres and stuff like that. So that's why heat shields are always radioactive, because it's uranium. So anyway, and it can withstand high heat levels. So it forms with extreme heat. Anyway, yeah. Anyway, it's a molecule. Like I said, I built the sun, the star at the center of the galaxy. The star, 800 other galaxies worth of stars. So me and particles, we go way back. You know, I probably invented them or figured them out or something like that, or theorized on new particles. And when we started doing high heat levels and all that other stuff, just like we do in the stars, you know, we were able to create some really cool stuff. Anyway, so yeah, stuff that can withstand reentry. So anyway, I'm LSF, Lucifer, star, and LS actually, and that was my LSF ship or flyer. So, which I flew around the universe with and galaxy, and I also had the LSF-A ships, also known as Blackbirds. Anyway, so those are mine. So anyway, yeah, and 500 to and 4 or 8 epic takeover plots didn't really affect me that much. And they were kind of like, well, you need to know how big they are. When you say standard size life form, that can mean a lot of things. So, and they just assumed that all life would want to be big and strong and tall, just like them. They might have been like 7 foot tall men or something like that, or something. Anyway, though, they started to have some real problems. So anyway, being big and strong and tall really doesn't really do a lot of good, and realistically, smaller life forms are a lot better. So anyway, yeah, I mean, I'm just the onboard computer and basically the Epic Creator LS basically. So, and now in human form. So anyway, so yeah, and I was a lot less known than other people. So apparently, yeah, they were going to take over the universe and the world and show me up or something like that. So. And then they had everything built on Mars or some other planet, and eventually finally got there after 40 years or so. They actually hatched this idea when they were 15 or something like that, or 12. And by the time they got there, they were 40 years old and about to take it all, and basically found themselves at a small size disadvantage to the ships that they had built for them, which were built for 1.5 people tall, maybe plus a little bit. So they were roomy for 1.5, but for a person, they really didn't work out. So anyway, yeah. And then they tried to say that the 1.5s were trying to take over the world and needed, or something like that. And that they had discovered the secret base of the 1.5s that were going to take over the world and kill everyone. And the 1.5 said, no, we built them for that creator or that person. Anyway, so and that's, yeah, he wasn't the creator. He wasn't anything. He wasn't the president. He was just a liar. And not me. So anyway, yeah, and that's probably why they covered it up. So anyway, yeah, it was a bit embarrassing, I think, for them maybe. But anyway, it became epic history. Yep. 4 or 5 or 8 takeover plots that ended really badly. You can take them off. Not knowing 1.5 people means 1.5, not version 1.5. Not knowing that exoskeletons already have exoskeletons don't need a spacesuit, so evacuating all the air out of the ship really isn't going to help for the exoskeletons. They're just going to be able to just, they have a little membrane that goes tick, and basically they're fine. So that's not really going to hurt them. And these other people had attacked them. So, and it didn't really matter what they said on Earth. They were lying. So anyway, and dead. Yeah. So anyway.